This is the second lesson for sections 16.2 and 16.3. We're going to look at some more examples of polynomials with real and complex roots. This next example here asks you to find a degree 3 polynomial with the coefficient of x squared equal to 10, and it has zeros of 5 and 5i. So we know this is going to have x cubed, and it's going to have 3 roots. We've got 2 of them here, and since we have I, we know we're also going to have negative I as a root. So again, if we list our roots, f of x is going to be x minus 5, x minus I, and x minus negative I, which would be x plus I. Again, it's easier to group the imaginary, especially since they're complex conjugates, when we're multiplying out first. So we've got the x minus 5, and then we're going to have x squared plus ix minus ix and minus I squared. Again, plus ix and minus ix is 0, and negative I squared is really a plus 1. So we end up with x minus 5 times x squared plus 1. Again, if we multiply this out, we get x cubed minus 5x squared plus x and minus 5. And this one asked that we have the coefficient on x squared being 10, so we need to adjust this so that we get this negative 5 to really be 10. So what we're going to do is we're going to multiply the whole equation by negative 2. And we end up with negative 2x cubed plus 10x squared minus 2x and plus 10. So that's all we have to do for that one. We're going to look at some more examples here. Sometimes we're given part of a solution and we want to find the rest of the solutions. This next example says that we are given one of the solutions, 4 plus I, and we've got a cubic equation, and we want to find all the complex roots. Again, we know since we have 4 plus I that we're also going to have 4 minus I, so there's one of them right there. Now we just need to find one more. And what we need to do is we need to figure out what roots these give us and then divide it into this and see what linear term we have left. So in this case we are going to have, we'll call this g of x is going to be x minus 4 plus I and x minus 4 minus I. Again, distribute that negative inside, so we get x minus 4 minus I and x minus 4 plus I. Again, we're going to expand here, so we end up with an x squared, a minus 4x, and a plus ix. When we distribute the negative 4, we get a minus 4x, a plus 16, and a minus 4i. And then finally, when we distribute the negative I, we get a minus ix, a plus 4i, and a minus I squared. Again, here we've got ix minus ix is going to be 0, negative 4i plus 4i is going to be 0, and again this negative I squared is going to give us a plus 1. So when we simplify everything down, we end up with an x squared. We have a negative 4x and a negative 4x, which would give us negative 8x. And then we have a 16 plus 1, which would give us plus 17. So this would have been the quadratic factor if we factored this out. So now we know that x cubed minus 6x squared plus x plus 34 is equal to some linear factor x minus a times x squared minus 8x plus 17. So when we go through, we can really just divide both sides here by this. And this one is a little bit more difficult to factor, so we're going to look at long division as our method for simplifying here. So this would be considered our second step. This is kind of our first step, and now we're going to look at our second step. So we are going to take our x cubed minus 6x squared plus x plus 34, and we can't use synthetic division here because again we don't have the linear term, we're actually looking at the quadratic term. So we're going to divide by x squared minus 8x plus 17. So we say, what does x squared need to multiply to give us x cubed? Well, we need an x, so that goes in the x column. X times x squared is x cubed. X times negative 8x is negative 8x squared, and x times 17 is 17x. Again, we're going to go through and change all of our signs here. So we get negative 6 plus 8 is 2x squared, and x plus x minus 17x is negative 16x. We're going to bring down that 34. And we're going to say, what do we need to multiply x squared by to get 2x squared? Well, we need a plus 2. That will give us 2x squared minus 16x and plus 34, which is what we wanted because that will give us 0 at the end once we change all the signs. So this is our other factor here. X minus a is x plus 2. So this would give us a root of x equals negative 2 if we subtract there. So we could rewrite this as x plus 2, x squared minus 8x plus 17. And again, our root here is x equals negative 2, and our roots from this are 4 plus or minus I, and we can write them together like that. That's fine. So these are our three roots. We've got a real root, negative 2, and we've got a 4 plus I with our positive imaginary part, and 4 minus I with our negative imaginary part. Let's look at some more examples. Sometimes it's helpful to use our calculator when we don't know what our real root is to start off with. So we want to find all of the complex root, that includes real roots, given a function equal to 0. We've got a quartic here, so we're going to have 4 roots. There's a hint here to use the calculator to find the first 2 real roots, so go ahead and get out your calculator. So with our calculator here, I'm going to put in our function. So we have x to the 4th minus 5x squared or cubed plus 6x squared plus 3x and minus 9. So 4x squared minus 5x cubed plus 6x squared plus 3x minus 9. And we're going to hit graph. Since this is equal to 0, we can just go through and find our zeros. We see that there are 2 real zeros here. This little bend here tells us we've got some complex zeros. And we go over to calc. We go to 0 here. We again give it that window a little bit to the left. We'll look for that first point. Go a little bit to the right of that first point, and we'll go back to that first point as far as a guess. And it tells us we have a 0 at negative 1. Okay. Now I want you to pause the video here and find the other real root. So you should have found that your other real root is at x equals 3. So again, those are our real roots, so we know that g of x here, again with step 1, is going to be x minus 1 times x plus 3. This one you could do synthetic division twice if you wanted to, but I'm just going to go through this to show you the steps for this. We end up with x squared minus 2x minus 3 when we do this. And then we go over to step 2. Step 2, we're going to do our long division. Again, like I said, you could have done synthetic division twice if you wanted to. In this case, we end up with our x to the 4th minus our 5x cubed plus 6x squared plus 3x and minus 9. And then we have x squared minus 2x minus 3 as our divisor. So we say, what do we need to multiply x squared by to get x to the 4th? Well, we need an x squared. X squared times x squared gives us x to the 4th. X squared times negative 2x gives us negative 2x cubed. X squared times negative 3 gives us negative 3x squared. Again, we go through, change our signs. We end up with 0. a negative 3x cubed, and a positive 9x squared. We need to bring down this next term, this plus 3x. We again say, what do we need to multiply x squared by to get negative 3x cubed? We need a negative 3x. And so we end up with negative 3x cubed, positive 6x squared, and positive 9x. Again, go through and change our signs. We get 0, we get 3x squared, we get minus 6x, and then we bring down our negative 9. In this case, we're going to need a 3 to multiply, so we're going to say plus 3. So 3 times 3x squared, so we get 3x squared minus 6x and minus 9, which is the same thing we have here, so we'll end up with 0 at the end. So this is our quadratic piece here. Again, this does not factor. So we have to go on to step 3, and step 3 in this case is going to be the quadratic formula. So in this case we've got a is 1, b is negative 3, and c is plus 3. So if we plug that into our quadratic formula, x is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times a is 1 and c is 3, all divided by, make sure you do all divided by here, don't just put it under the radical or under the first part, it goes under everything, 2 times a is 1. So we end up with negative 3 is 3, plus or minus the square root of 9 minus 12 over 2. Keep simplifying. We get 3 plus or minus the square root of negative 3 over 2. And we can't take the square root of 3, but we can take the square root of a negative number, and we get 3 plus or minus I root 3 over 2. Again, that I comes from the fact that we had a square root of a negative, but the 3 stays inside. Again, we can't simplify any further. So our roots in this case are x equals negative 1, 3, and 3 plus or minus I square root of 3 over 2. If you wanted to split this up, you could split this up as 3 halves plus or minus I square root of 3 over 2. Either one is acceptable. It just depends on what the problem is asking for. If it wants you to split up the real and imaginary parts, then you would need to do this for that answer. So I want you now to try example 18. So this one you actually didn't have to do a whole lot of work for. They tell us that we have the root I has multiplicity 2, meaning it shows up twice, and we have this real root x equals 3. We have a quintic equation, and that means we're going to have 5 roots. Well, 2 of them are here with this I, 2 of them would show up with our complex conjugate negative I, and then we have 1 with our root 3. So that's really all we have to do for that one. So ultimately what this tells us is that x to the 5th minus 3x to the 4th plus 2x cubed minus 6x squared plus x minus 3 could be factored into x minus I, and we have 2 of them, so it would be squared, x plus I, because that would be our negative I, again we have 2 of them squared, and x minus 3. So one last example here, we want to find all the complex roots for this problem. Again, this one does not factor nicely, so we want to take a look at the calculator first, and I want you to pause the video here and try this example, then resume to see if you've gotten the correct answers. So for this one, you should have used your calculator to find the roots of -7 and 2. I did show how you can do this with synthetic division. You can do this twice with synthetic division versus the long division if you choose. It's a little bit faster this way. First time through you would end up with x cubed minus 3x squared plus 5x, and minus 6, and then you'd repeat the process and you'd end up with x squared minus x plus 3 as your quadratic factor. So again, up here what this is saying is that we could factor this into x plus 7, x minus 2, and then x squared minus x plus 3. The x squared minus x plus 3 does not factor. We need to use the quadratic formula. And we should end up with 1 plus or minus I root 11 over 2. So our roots end up being negative 7, 2, and 1/2 plus or minus I root 11 over 2. Again, this gives you your positive imaginary and your negative imaginary roots if you have to split them up into the real part and the imaginary part. Either one of these is technically correct. It just depends on what the system is asking for. So this concludes the lessons for sections 16.2 and 16.3.